So today we're looking at missing angles in quadrilaterals. Now, with this exercise, you will be combining facts that you already know about angles, straight lines, angles in a triangle, obtuse, reflex, etc., 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 with the fact that every quadrilateral, the internal angles of a quadrilateral are 360 degrees. So this could form random quadrilateral, just any four-sided shape, or it could be a recognisable quadrilateral that you already know about. For example, this is a parallelogram. Now, when you're working these out, you need to give your reasoning as you go, okay? You need to explain what angle facts you are using, and this reasoning is part of it. It's no good just showing the calculation, you have to state them in words or phrases. So let's have a look at this first one here. Now, as you can see, we need to find two missing angles, A and B, and we've been given three angles rather, 121, 100, and this angle here. Now, again, this is standard notation, and that square means that that angle there is 90 degrees. When you're working on these, if you have it in a worksheet format, it's worth printing it out and writing on the sheet, okay? You can do it looking at a screen, but it's much easier to record things as you go. So this one here is 90 degrees. Now, likewise, we need to find two, A and B. The best way to do this is to work with the letters, work alphabetically. Now, sometimes you may find a way in using skipping a letter and then returning to it later on, which is fine. But often, if you can't see a way in, look for the word alphabetical, and that often helps you find the way. So, starting with A. We can clearly see we need to find this angle here. And we know it's one of the internal angles of the quadrilateral, but we also know it's one of the two angles here, which is on a straight line. Now, we know a straight line is 180 degrees. Therefore, we can say that 180 degrees minus 121 will give us angle A. .59 degrees. So again, you're writing it on the diagram as well as showing your answer with your reasoning. Now let's work out B. We already know 100, 59 and 90. So we know angles in a quadrilateral. I just realised I haven't crossed the T in quadrilateral up there. So we've stated for our angle reasoning, angles in a quadrilateral of 360. So if we take the 100, the 90, the 59, add them together, 249, and then if we take that 360 and subtract the 249, we can then get the correct answer. 111 degrees. Okay, so to recap, we're stating our reasoning and we're showing our calculations. Okay, let's move on to this one. Now, this also includes some standard notation. We can clearly see these two sides are parallel and equal length. These two sides are parallel and equal length. These two sides, oh, I've said that twice, I don't need to say it twice. We can also see that this angle here is 78, but we've also got another fact in here, and that's the double angle lines here. Now, in this question, I've labelled it C and D. However, you may want to, sometimes, not you may, sometimes the question may say that is C and that is also C, showing that they are equal in both, in two different ways. Be prepared for either. Okay, we know that this is a parallelogram. Okay, we can know this because of the notation, so we can state that as part of our facts. Therefore, because this is a parallelogram, we know that opposite angles are equal. So 78 degrees equals B, because the angles, the opposite, diagonally opposite angles are equal. Therefore, we know that that is 78, that is 78 degrees. Hence, we can then work out these two, because 78 degrees plus 78 degrees gives us 156 degrees. We know that angles in a quadrilateral (360 degrees), therefore 360 degrees minus 156 degrees gives us 204 degrees. And because C is equal to D, it means that we can take that 204, divide it by 2, 102 degrees, 102 degrees, 102 degrees. Because, again, those two angles are equal, we know this because of the notation, double, double. And again, sometimes they might put the same letter twice. But then we can do a quick check that 78 plus 102 takes us to 180. 280s make 360. So we know this question is correct. Likewise, you will see that I have not gone straight from that to the answers. We've shown all of this working, and this is the mathematics, okay? This is where your marks will come from. Normally, these types of questions are 3-4 mark questions, depending on how many parts you've got to do. And it is this reasoning and working out here that majority of the marks come from. The final answers are possibly only worth half a mark, if that. This is your mathematics. This is the key. As always, I've now got 2 questions for you to do. Okay, please note this shape. These two sides are parallel. These, oh, I've done this. I've just realised I put the wrong length. I've done that on the wrong bit. These two sides are the same length. Ignore those 2 marks. Drat. While I pause it, I might get the magic liquid paper out and their marks might disappear. Pause the video. Work your way through carefully, remembering the facts like angles on a straight line. If you've got a double notation, it means the angles are the same. And likewise, what type of quadrilateral is this one? Same principle here, very similar to the question we've done earlier. Straight lines, quadrilateral, and although we've only got one angle within the quadrilateral, we have got another one which is labelled, but the number is not given. As normal, pause the video and then come back and go through the answers. And as if by magic, the diagram's corrected. Right, let's have a look at these answers. Now again, we're looking for a way in. I'm going to start with A because I'm looking for alphabetical to help me. So the first fact we have here is that on a straight line are 180 degrees. Therefore, 180 degrees minus the 120 degrees gives us 60 degrees, which is angle A. Also, from the information we have here, we have one pair of parallel unequal sides. we have opposite sides which are equal in length. Therefore, this shape must be a trapezium. But it's not just a trapezium, it's an isosceles trapezium. I need to double check how you spell isosceles again. We'll get that corrected. So, if it is an isosceles trapezium, we therefore know that those two angles are equal, those two angles are equal. So if A is 60, B must also be 60 degrees. And again, because it's an isosceles trapezium, we know that those two angles are equal, and we know that those two angles are equal. Therefore, we know that we've got 60 plus 60 gives us 120. If we take the 360 minus the 120, gives us 240. And if we take that 240, because these two are equal and split it equally, we get 120, which therefore gives us the number of degrees. Now, you will see that here, this line here, this angle here, and that angle there are in fact equal. Now, next year we will explore this in more depth, and this is all to do with angles within parallel lines. And actually, we could say that these, well, we can say mathematically actually, that this angle here and this angle here are alternate. Okay, so we could use that as angle reasoning as well, but I will explain more, or whoever you've got for maths next year will explain more in Form 8. Right, okay, let's have a look at this one then. Again, A, B, and this unknown here. Well, it's an unknown, we haven't got a number attached to it, but we know that that square like that means it's a right angle. Okay, let's have a look. We have a straight line here again. Angles on a straight line 180, therefore 180 degrees minus 135 degrees gives us 7,154, 45 degrees. Okay, we also know angles in a quadrilateral are 360 degrees. Therefore, we can take the 45, we can take the 125, we can take the 90, add them up, 260, so therefore 360 degrees minus 260 degrees gives us 100 degrees. Now, just a quick thing it's worth mentioning, these diagrams are not drawn to scale, okay? They are just purely for the calculations, not measuring. So be aware when they say calculate, we're expecting you to calculate. We know that angle should be an obtuse angle because it's 100 degrees, but in the diagram it looks like an acute angle. If I was to accurately construct it, this diagram would look very different. But because these are not drawn to scale, it means that you can't measure them, you're calculating them. And these calculations here, like I said earlier, are the key, are the most important part.